So next we'll go to the another case, that is case B. So this is of residential property, means for the house application, how it will going to vary. So location which is considered UK with a latitude of 52° north, and of course first we need to know what is the annual solar radiation. So that is approximately it was 970, less enough, 970 kilowatt hour per meter square per year, because we are considering under the residential property. And again the planes are you are going to keep the planes in the horizontal panel itself. And as for the temperature, you are assuming that daytime model temperature can be varied from 0 to 50°. So minimum 0, maximum 50°. Again, what is the system? What are the different arrays you are using it? We'll see to it. So one 3.08 kilowatt per array linked to a 6 kilowatt inverter, means this is the array capacity, and that is connected to inverter of 6 kilowatt. The inverter is oversized to allow for further expansion of a PV array, because initially for residential and all, like first we'll go for a trial versions, and if you feel better then you can go for the extension. That's what they say. Initially you're taken the oversized, where if you want to extend the PV array system, and the system has been sized to meet the electrical demands of the household, mainly for residential. As I said, household application has to be satisfied, and that is expected that annual electricity production from the PV system will meet annual electricity consumption, means how much we get it from the KEB or MESCOM, BESCOM, whatever in North Karnataka. So that much of electricity should be produced from this installation. And when they have installed, you can see it was commissioned on 20th February of 2010, and as of 20th January 2011 has generated 3,113 kilowatt hour of electricity, with 2,897 watt per being metered at the distribution board. Means they are giving the clarity in 1 year how much it is produced, because it has to set, you have to get the output same as the electricity which you consume from the other sources. So that's what, when you consider with a 1 year warranty or 1 year span of a time, so you have got a good generation. You can see 3,113, it's not a small amount, but considering all losses, those many things, you can say minimum 2,897 watt hour that was distributed in the board. That is a meter which is displayed how much you have produced. So you're going to get it as 2,897. Let's see with respect to PV array, what type they have used and what was the capacity. So the array comprises of 14 sharp ND220 polycrystalline silicon modules. So type is polycrystalline, and of course this is with respect to the company, and they taken 14 cells. Okay, so and each is having the 13.4% efficient. And array output varies significantly over the year, because we know that first 5 years will be something out like output will be 98, 99%. Then after 5 years it comes to 95, then 90. So definitely it will vary years. Then in the third week of the June 2010, the system exported an average of, so they have taken the third week average, that is 17.2 kilowatt hour per day. But it is only exported 1.34 kilowatt per day in the third week of December 2010. Means as the season changes, we know that June of course, which season it is? June, winter, rainy or summer? Guys, which season?
Monsoon, ma'am.
Monsoon. Okay, December?
Winter.
Winter. Okay. So monsoon means, so now of course where there is so much of variation, so we can take approximately by better sunny compared to the cloudy nature. So in that cases, see the output to the expected is 17.2. Exported average of power is 17.2. Similarly, December, as you said, winter, so the power is very, very less, that is 1.34. Because year wise, when you say different months, different output will be there. Okay, so that's what they say. Modules were covered by the snow for a part of the week. So we have just taken an example of our place, but it is in the place where they have a polar region. So snow will be fall on the surface where it is not going to produce much amount of output. So that's what exported power is just 1.34. So here you can see the inverter is manufactured by Franis and located in indoor under the stairwell within 1 meter of the distribution board. Means given the very less space, and you can see the number is visible, 2547 kilowatt hour. It's a good amount of power has been produced. And this is the house where they have installed. See, in order to meet the household energy demand, 14 PV modules and the 3 solar thermal collectors have been installed. So from here itself, you can observe the structure is polycrystalline, and number of modules you can calculate also, 1, 2, 3, 4, 5, 6, 7. So 7 into 2, 14 PV modules are connected. Okay, so this is completely for household application. So what is the mounting structure? Can you tell me? Is it a roof mounting or a ground mounting? Roof or ground? So this is the first title, roof mounting itself. It is not tiled also, metalled also, normal roof itself. Okay, so you can see standoff mounts have been used to allow some ventilation beneath the array, and the roof faces south, so the array could be installed at the tilt and orientation of the roof itself. Means no other designing, nothing you people are doing it. Already your house construction, you can see here, already have a tilted nature. So just you're stuffing your roof panels on the surface, but horizontally fixed. Small gap has been maintained between your roof and the module to get a better ventilation. And of course, moving towards, you can say, ma'am, why can't I connect it on the other side? That is say south towards with some angle. So better they select the highest range of sun falling on the system. So next is economically, what they are invested and what FIT they are getting it, and how much they are recovering the system. So as of April 2010, the system owner receives $0.1 per kilowatt hour under the UK government clean energy cashback scheme, a grass fed in tariff. So lucky person, he has installed that under a FIT of government clean energy cashback scheme, where it is going to sponsor $0.14 for every kilowatt hour of power. Okay, the income earned from this scheme, that is including the feed-in tariffs and saving in the electricity bill. Of course, you see, when you heard this term, including the feed-in tariff and saving electricity bill, of course, it's time for recovering the installed amount, means invested amount at the beginning will be very, very less. And she will be the benefiter for the remaining years, means longer remaining years you're going to get it. So it's expected to amount to $1,674 per year. So definitely what has happened, if it residential cases, is going to reduce the carbon dioxide emission by 1,643 kg per year. Means this is all case study, as I said, how it will going to reduce with the plant. So these kind of example they've taken. So carbon dioxide is reduced by 1,643 kg per year. And from June 2011, the UK government renewable heat incentive (RHI), a similar scheme to FIT, will pay $0.18 per kilowatt hour for zero carbon heat generated by the solar thermal heating system. I think that owner is very lucky person, because initially he got $0.1. So now addition to that, because of carbon emission which is reduced, so he is again benefited with $0.18 per kilowatt hour. So you can count it as 0.41 plus 0.18. So almost more than 0.5, he is going to get the benefit. So for the zero carbon heat generated by the solar thermal heat system, which is at 20th January 2011, has generated 1,774 kilowatt hour of the heat. And as the combination like FIT and RHI incentive schemes mean, the capacity recovery will be less than 10 years for both the systems. So he's getting a more advantage, because instead of an investment, he's getting different incentives for the carbon emission as well as for the FIT for installing the renewable source for the energy production. So this is one of the basic diagram, how the winding diagram has been carried out. A wiring diagram of the PV system installed by Solar UK for a planet energy solution. So PV arrays, so you can see the output, that is of 300 to 400 volt DC, and we have a DC switch, and output is connected to inverter. Inverter to next we have a AC switch, and that is connected to the generator meter, and afterward fuse box, then grid system will be available. But when you say household and all, so grid system will not be connected, only for self purpose you are going to use it. So you can see high DC and AC voltage isolate panels before working on PV system padlock, AC switch off before working on wiring. So this is just a representation. Because if you want to working on a lesser value also, no issues, switch off and use it. But sometimes by mistake, the low voltage and all, if you touch, you may feel the experience. But high voltage you cannot play, so you have to switch off and you have to work it on it. Okay, this is with the second case for